All right, team. Here is some more classwork for Wednesday, September 23rd. The other video is pretty short, so I think you guys can handle this. So these are the next 4 pages that we're going to be going over in the packet. So just continuing with what we were doing in the last video. So we're going to talk about identifying the constant of proportionality, which, yes, we have talked about before, but now we're introducing it in graphs too. Then we're going to talk about the proportional equations, which, yes, we have talked about before as well, but now you'll see what it means in the graph. Okay. So let's start here. Identify the constant of proportionality. So the key concept here is quantities are proportional when each measure in the first quantity is multiplied. Let's write that. Multiplied by the same constant to give the corresponding measure in the second quantity. So keyword there is constant. Remember, constant is the same thing as unit rate. Okay, same thing as unit rate. So actually, let's just write this bold and underline it and make sure everyone's totally clear on this. I'll do it up here. Unit rate equals, that should be an equal sign, equals the constant, and both of those are represented by the letter K, and you can find the unit rate, the constant, or K, by y divided by x. Okay, so that's pretty much the key concept there. Okay. All right, so let's look at the table example we have here. So we're first asked to determine the constant of proportionality by finding y divided by x. So again, that's just your unit rate. Okay, so we're going to take each pair here and divide y by x. So y divided by x. Okay, so the first one we have is, and I would write the steps out on this first one just so you can look back at it later when you're working on other stuff and see what you did if you get stuck. So the first one, we have 12 divided by 3 is 4, so that's that one. And we have 20 divided by 5, which is 4. Then we have 8 divided by 2, which is also 4. And lastly, 32 divided by 8, which gives us, surprise, 4. All right, I do recommend calculating each of those unit rates because sometimes they'll, trick you, and one of them will be different than the other ones, which means there's not a constant because they're not proportional. Okay, so because all of them are equal, though, because they all equal 4, that means that our unit rate, K, or our constant of proportionality, K, is 4. Okay, so if we kind of reversed things, right? If we reverse things and we had X, but we didn't know our Y values, we could take X and multiply it by 4 to get our Y values, right? So instead of going this way, we could also go the other way, right? So 3 times 4 is 12, right? 5 times 4 is 20. 2 times 4 is 8. 8 times 4 is 32. Okay. Oh, hi, Jim. Sorry, my dog just came to get some attention. Okay, so that's a review. We have talked about this before. If it doesn't ring a bell, hopefully that helped. But let's talk about graphs now. Let's talk about graphs for a second. So in graphs, the constant of proportionality, or the unit rate, is identified by the point 1, R. So basically you're looking at whenever this variable line is 1. What is the matching y value? Okay, so if that doesn't make sense, let's do a quick review of graphs. Okay, I'm going to draw you a lovely graph here. So when we have a coordinate plane graph, which is what you see there, we have our two variables, our x variable and our y variable. So your independent variable is the horizontal line. Okay. Your dependent variable is the vertical line. Okay. So an easy way to remember this that I know they talk about in science too. Pretend that this is a wall and this is the floor. Okay. The wall can't stand up if there's no floor, right? It would just topple over. Okay. So the wall depends on the floor to be there. So the wall, the y variable, is your dependent variable. Hopefully that helps a little bit. Okay. There we go. So we have our axes now. We would always have some kind of scale, so some kind of number line. I'm sure you guys have seen these before. Sometimes they'll count by 1, sometimes they'll count by 2s. Whoa, I wrote 2. Just draw you this real quick. Okay. You will also go into the negatives, but we'll not worry about that right now. So, not yesterday. The last video we talked about the origin on a graph. Remember, the origin is that point 0, 0. Okay, so it's the center of the graph. The origin. It's the point 0, 0. Okay. Now, there will always be, well, not always, there will be points on the graph when you're working with these types of problems. So you could have like a point right here, or a point right here, right? Or right here. Okay, and usually the points will be connected by some kind of line. Okay, that should be a straight line, but you know, I'm not perfect. Okay. Now those points, they're called coordinate points. Coordinate points. Or coordinate pairs, you'll sometimes see. Okay. Those coordinate pairs are basically your x and y values for each of the pairs in your table. Okay. So let's actually erase that and pretend that we're graphing the points in this table. With your coordinate pairs, the x value will always be first. So when you're graphing points, you're going to count from the x first. So always start at the origin and then count. So our first pair, I'm going to do 3, 12 to show you. So we would go over 3 on the x because that's where the x is. The x comes first. And then we're going to go up to 12. So it'd be like up here somewhere, if that's 12. Okay. And that's where the point would be. Okay. So always go always go over on the x first, then up. Okay. Over, then up. So that's basically how you graph points given a table. Okay. Those pairs in your table become the coordinate points that you graph, the x and y. Okay. So you could also graph the point 5, 20. So over 5, up to 20, right? You could do 2, 8. So over to 2, up to 8. Okay. You'd have some kind of line going like that. All right. So there's some basics of graphing. I'm going to take off some of this so it's not so messy. That's probably good. Okay. So what it means over here where it says on a proportional graph, the constant of proportionality, or the unit rate, is identified by the point 1r. So think about when you find the unit rate. So this unit rate, for example, if we put that in our table, so we extended the table, we would say that's 4 and that's 1. Okay. So that's referring, this is referring to this pair, but we're just rewriting it in ordered pair form. So whenever x is 1, so if you ever have a 1 in that first number of a coordinate pair or a coordinate point, the other number, the y variable, will be the unit rate. Okay, so if we had the point 1, 4, that right there would be our constant or unit rate. I don't know what I just started smelling. So if we were talking about like cookies sold and money earned for the y variable, we would say that for every 1 cookie sold, we make $4. Okay, or $4 per cookie. Remember, per means unit rate or constant. Okay, so hopefully this makes a little more sense now that we've kind of done some basics of graphing. So if you're ever given a graph and you're told to find the constant of proportionality on the graph, you're going to look for that x, or sorry, the x value of 1. Okay. All right. So if we kind of zoom back in over here. So this says remember, which maybe you're not remembering, you're learning for the first time, and that's totally cool because you probably are. If the point 1r is not easily identifiable, so if it's not easy to point out, kind of like this is, like it's this point right here is right on the cross, so we know exactly where it is. Whereas if you had a point like right here, we don't know if that's like 9 or 9.5. So that's what I mean by easily identifiable. I guess I should finish writing that word. If the unit rate is not easily identifiable on the graph, simply pick another point that is easily identifiable and divide the y by the x. Okay, so just finding the unit rate there. So for example, if we, let's see, I'm going to draw you a quick example. So we have this problem, and so remember proportional relationships in graphs will always have a straight line and go through the origin. So that's what I just drew. So if we look on here and we try to find the point that goes with 1, it'd be somewhere right there. So it's the point that when you go up from 1, it's wherever the line is. Okay, but it's not totally clear what that number would be. It's less than 1, but it's not 0. It could be like 0.75 or something. We don't know. So what you would do is find a point that is easily recognizable. So in this case, there's a very clear point. That's the point 3, 2. Remember, your x goes first, then your y. So it's the point 3, 2. Okay, x and y. So to find the unit rate or the constant from there, we would just do like what we have been doing with the unit rate. So we would write our 2 over 3, and we would divide them, 2 divided by 3. That'll give you some decimal. Basically, it just simplifies to 2 over 3. Okay? It'll give you like 0.6666667, right? So it's the answer is 2/3. Okay, so here, right, we guessed 0.75, which would be 3/4, but it's actually 2/3 or 0.67. Okay, so if there's not a if the unit rate is not easily recognizable on the graph, find another point that is very clear, and this just divide the y by the x. Okay, hopefully that makes sense and helps you out a little bit for this page. So basically, we're going to be identifying the constant in tables and graphs. Okay, I'm going to go over one of each with you, and I'll let you do the rest. Okay, so let's start with the first one here. Number one. Oh, and notice that this one right here is a little tricky because you got to fill in some blanks too, right? So do that with equivalent ratios. Remember, you can divide or multiply to get things. That's the only hint I'm giving you there, but if you have questions when you're working on it, please email me. Okay, number one. We have minutes and gallons of water. So the first thing I would encourage you guys to do, I'm actually going to write this. The first thing you should do is, I guess I'm cutting that off. Let me scoot it down a little bit. The first thing you should do is identify the x and y. Whoa. The x and y. So which is this your x or is this your x? And which is your y? That's what I mean by that. That's going to be super important because we have to divide y by x, not x by y. Okay. Sorry, I'm yawning at all the videos today. Tired. Can I tell you a funny story really quick? So if you don't want to listen to this, you can skip forward. So the reason I'm tired, so I have 3 dogs. One of them is about a year old. He hasn't quite figured out life yet. But we have a lot of fruit trees in my backyard, and every time he goes outside, he eats probably like at least 5 apples. Like he'll literally jump up and pick an apple off of our apple tree or a pear off of our pear tree and eat it. Like he just loves fruit for some reason, or he thinks he's starving. I don't know. So he'll eat lots of fruit, right? So I don't know if you guys know this, but when you eat lots of fruit, it's not great for your digestive system. So he woke me up at midnight to do some business. So I let him out, and he was outside for probably like 20 minutes. And as soon as he came back in and I closed the door, he did the business inside. Like, really? You were outside for 20 minutes? And you had to do it right when he came back in. And then he did the exact same thing at like 5 in the morning. Ugh. So that's why I'm yawning and tired. Hope you enjoyed that story. Okay. So after you identify the x and y variables, I do get distracted and go off on tangents a lot in class. So welcome to the tangents of Miss Monson. All right, so after you identify x and y, the second thing you're going to do is calculate the unit rate of each pair. So each pair of values is what I mean by that. And third, let's do blue. Third, if all are equal, it means that they are proportional. And that number, the unit rate that you get, is your constant. If they're not all equal, then it's not proportional and there is no constant. Okay. So let me actually write that down. If not all equal, it's not proportional, and there is no constant. Okay, so there is one difference between unit rate and constant. I know I keep saying that they're the same thing. Really, the only difference is that constants, we're talking about like, oh, I don't know what just happened. Constants, we're talking about kind of like groups of equivalent ratios, right? So proportions. And while each of them have a unit rate, a constant will be the number or the unit rate if they are all equal. So if they're not all equal, so if these are not proportional, there is no constant. They'll each have their own unit rate, but they won't together have a constant. Hopefully that made sense and didn't just confuse you really bad. But if you have questions on that, let me know. Okay, so let's zoom in and do number 1. So we're going to follow these 3 steps. The first step is to identify your x and y. So basically we're going to see which of these we think depends on the other one. So does time in minutes depend on the number of gallons of water? Or do gallons of water, maybe gallons of water used, depend on how much time has passed in minutes? Now, you may be thinking, well, just give me the answer. But hopefully you thought about it. Hopefully you thought about it. In this case, gallons of water would depend on minutes. Usually if time is involved, time will almost always be your independent variable. Almost always. Not 100% of the time, but almost always. Okay. All right, step 2, calculate the unit rate for each pair. Okay, so again, to do that, we would do, I'll write this in parentheses, y divided by x, okay, the unit rate. So we're doing this number divided by this number, okay? So, I don't have a calculator in front of me, but I have my answer key that I made. So if we do 252 divided by 7, we get the answer 36. 396 divided by 7. I would encourage you guys to kind of to pause this and do it, and then check your work after, but we'll just keep going. Oops, I don't know why I said divided by 7. Divided by 11, because my dog jumped on my lap and distracted me, is 36. 540 divided by 15. And if you don't believe me, you can always check my work. Totally fine by me. 648 divided by 19 is 36. So because they are all equal, this number right here will be our constant. So they are proportional. They are, it's hard to write small on this thing, proportional. So the constant, K, is 36. Now, one thing I would encourage you guys to get in the habit of doing is writing what variable it goes with. So is it 36 minutes or 36 gallons of water? So if you're not totally sure, just remember that when we write our unit rates, one will be the denominator, and then you'll have some number on top, okay? And when we write fractions with ratios, y is always on top, x is on bottom. So the x is going to be your 1. The other number is your unit rate or your constant. So in this case, since 36 was the number, we know it's not x because x needs to be 1. So here it would be 36 gallons of water per, or for every 1 minute. Hopefully that made sense. Again, if it didn't, please email me while you're working on this, okay? So I want you guys to do, guys and girls, ladies and gents, everyone, to do numbers 2 and 3 by yourselves. Make sure you show your work. So what I mean by that is basically do what I just did, okay? I've mentioned this many times, but I do not grade assignments if there's no work shown. I'll mark it as a retake, hand it back to you, and won't give you a grade till you show your work. So please make sure you show your work. So pause the video, do 2 and 3, and then unpause for 4, 5, and 6. Oh, there goes the yawn again. Okay. All right, hopefully you paused the video and did 2 and 3, and hopefully it all made sense and everything is awesome for you. If not, please email me or message me on Google Hangouts. That one's the fastest way to get a hold of me. So I'm going to do 4 with you, and then you guys are going to do 5 and 6. Okay, we're going to follow the same steps as before. So the first thing we're going to do is identify x and y. Now, if we have a graph, the horizontal line, the one that goes this way, like the horizon, if you were looking at the sun, there's our sun and some clouds. I promise I'm actually a decent artist. Okay, so the horizontal line is your x-axis, and the vertical is your y-axis. So if we were to write our y over x ratio, we're talking about inches of rain over hours. Okay, so we need to identify the constant of proportionality. Now remember, with graphs, we are going to look for the point 1r. Okay, and r is going to be whatever number y is when x is 1. So let me write that out. What is y when x equals 1 on the graph? Okay, that's what we mean there. Hopefully that makes sense. So if our x value is 1, that's what we're looking for. We're going to go up till we hit the line, or if there's a point there, we go up to the point. And then we're going to look at the y value that matches that point. Okay, so how we get that point. And that right there will be your unit rate or your constant of proportionality. Okay, and we know for sure that this is a proportional graph because it goes through the origin and it's straight. So 4 then is definitely our constant. But what are we talking about? For what? Well, it's over here. So we know we're talking about 4 inches of rain in 1 hour. So for every 1 hour, we get 4 inches of rain. That'd be a lot of rain. Okay, hopefully that made sense. Hopefully this is all just awesome and a breeze for you. If not, no worries. This is a new concept, so it won't always be easy. Okay, but let me know if you have questions. So you're going to do 5 and 6. 5 and 6 all by yourself. You're going to show your work. Okay, basically with showing your work on graphs, you're going to essentially just kind of highlight where the point is okay, and write the point out. I guess I didn't do that. 1, 4. That would be showing your work, okay, and then your answer, obviously, we would need. Okay, hopefully that makes sense. I do want you to have a reflection question here. What I want you to answer is how do graphs and tables relate in this lesson? So you could talk about, you know, the points on it, the pairs, you could talk about unit rates, anything you want, as long as you're answering that question in a full sentence. Okay. All right. We'll actually pause that here. I think that's enough for Wednesday. Actually, I'm not going to pause it. No, I'm not going to pause it. That's as far as you should go Wednesday. Okay. And then Thursday, we'll jump into this. So if you want to just keep going and do more work on Wednesday and less work Thursday, that's awesome. Okay. All right. So pause, take a break, grab a drink of water, some Gatorade, whatever you want. Grab a snack, come back, or take a day-long break, come back tomorrow. Okay, here we go. The next section we're going to do is all about proportional equations. And again, yes, we have seen this before, so it should be kind of a review. And if it doesn't look familiar at all, well, hopefully this will help. Okay, so key concept with proportional equations. Proportional relationships can be represented by the following equation. Y equals K times X. Now, when you're asked in a question to actually write the equation for the problem, you're going to replace X. Or sorry, not replace X. You're going to replace Y. Replace, oh my gosh, did I say Y? You're going to replace K. I promise I know what I'm talking about. You're going to replace K. The Y and the X you leave the same. Okay, but what are Y, K, and X? Let's talk about it. All right, so the Y is basically we could call it the output because it's dependent on the other one. So it's going to be your dependent variable. Okay, the dependent variable. So if we're talking about cookies sold and money earned, well, however many cookies are sold affects or gives us a different outcome of how much money we get, right? So that's what it means by output. Now K is your constant of proportionality, or we could say your unit rate. Now remember, to calculate K, you would do Y divided by X. Usually you'll just see Y over X, but that's what it means, Y divided by X. Okay, X then is going to be your, basically what we could call your input. Whoa, I don't know what is happening there. Your input, which is essentially your independent variable, right? It's the one that we change. It's how many cookies we are selling or how much time has passed, right? For example, independent variable. I guess I should finish writing the words I was saying. Okay. So we have our input, our constant or unit rate, and our output. All right. Let's talk about this part. Determining the value of K. So remember, K is just talking about the unit rate or the constant. Okay. All right, so we kind of looked at this part already in the last one, but if we're determining the value of k or the unit rate or constant in a table, we're going to find y divided by x, right? If there's already an x, so if this is our x, this is our y, if there's an x in your table that's 1, then that number will be your constant, okay? So look for that. But let's determine if these are the x and y, if I wrote that down correctly. So we have bottles and money earned. Now, if we're ever talking about money, 97% of the time it will be your dependent variable, right? We can't earn any money if we haven't sold any bottles or recycled any bottles, right? So money is going to be our y, our output, our dependent variable, and x is going to be bottles, our input, our independent variable. Okay, so in a table, again, we'd find y over x, y divided by x, y divided, that's what the sign means, divided by x. Okay, so we would check it for each of them. So I'm going to do this. Okay, so we would want to start with 0.40 divided by 4. We'd want to do 1.2 divided by 4 and 5. What did I write 4? I don't know. And what just happened? Divided by 12 and 5 divided by 50. Okay, so if we have a calculator and we do this, I encourage you to pause it and calculate it yourself, but we get 0.1, 0.1, 0.1, 0.10. Okay. So since they are all the same thing, they're all equal, then that would be our k, our constant, 0.1. So we would write k equals 0.10. Now remember, it's 0.10 of whatever the y variable is. So in this case, $0.10 earned, or 10 cents earned. So that's how we do it in the table. This should be a review. Now the graph, we just talked about this one. We're going to look for when x equals 1, what is y equal to? Okay, so if we look at our graph here, remember that x is going to be, I wanted to use green. X is your horizontal axis. Y is your vertical. Remember, the wall depends on the floor. Okay, now we're going to look for when x equals 1, what is y? So we're going to go up from there till we hit the line. We're lucky because it's right on the line there. So it's perfect. Our y for this one then would be right here. Okay, so we would write the same thing. K equals 0.10 earned. Okay, so when x equals 1, what is y? Okay, if we're talking about just a description, so we're given just a word problem and we need to find the unit rate, we could say something like, for each plastic bottle that Zach recycles, for each, key thing there, he earns 10 cents. Okay. So there it already gives you the unit rate, so you don't have to divide anything here. If it said something like for every 4 plastic bottles, he earns 40 cents, right? Then you'd have to actually divide y by x. But in this case, we are already told the unit rate without having to do anything. Remember, each means 1, right? For every 1 plastic bottle, which is what we see here and here, for every 1 plastic bottle, he earns 10 cents or $0.10. Okay. Now the equation, usually you will always be asked the equation with this. The equation, again, is going to be that y equals kx. So let me rewrite it down here. And I'm going to rewrite it in a couple different ways to make it very clear what we do. So that's the general equation, but we need to actually replace k. Remember, the only thing you replace in the equation is the letter k, and you would write the unit rate in place of k. All right, so I just want to make it clear what we're actually talking about in this scenario. So here we're talking about y, so money earned. The money that Zach earns is equal to the amount of money we get per bottle, so per bottle, times however many bottles we've recycled. Okay. If you ever see two things next to each other in parentheses or just like y equals kx, it means we're multiplying. Okay, but I don't want to put the x there and confuse you. I'll do the dot. There you go. It means multiplying. So if we want to find out the money earned for 20 bottles, right, we would substitute 20 in here, multiply it by the unit rate of 0.10, and that would give us our answer. Okay, so that's why the equations are really useful, and I know we've talked about that briefly before. Okay, so what would our actual answer to this question be? What's the equation? Well, our equation would be y equals the unit rate, which is 0.10 times x. So the only thing you replace, oops, I meant to do that in black. The only thing you replace when you're asked the equation is k. Whew, that was a lot. Okay. We got this. Now we have some practice. All right. I want to see what you guys can do by yourself on this one. Do I? Yeah, I do. Yeah, I do. I was just looking over them again. So when we did the example over here, all 3 of those, the table, the graph, and the sentence, were all one problem. Please note that here, each of these are different problems. Okay, so we're talking about walking miles and hours here. We don't know what the variables are here. We're talking about movies and cost here. Okay, so they are separate problems. They're not all one problem. But what you're going to be doing is 1, finding the constant. So what's the constant? And then you're going to write the equation in the form of y equals kx. Okay, so two answers you need. You need the y equals kx, where you're replacing k, and you need k equals whatever the unit rate is. Okay. All right, you got this. If you have any questions, seriously, if you're struggling at all, please message me on Google Hangouts and I will help you, or email me if that's better for you. That's fine. You could also Google this kind of stuff, like how do we find the constant in a table? Or you could rewatch some of this video, whatever works for you. Okay. And one more thing I want to rewrite on this really quick before you get started. Don't worry about the reflection question on this one. But remember the steps to do. You need to find out which of those variables is X and Y. So is movie tickets X or is cost X? Is this X or is this X? Right? This one or this one. Is this one X or is this one X? So determine which one's X, which one's Y first. Okay. Then you're going to find the unit rate. Unit rate slash constant, or K as we call it. All right. Then you're going to write the equation. All right. Awesome work, team. I'll probably post some more stuff for Thursday since this part of it wasn't super long. But we'll see. We'll see. Okay. If you have any questions, please let me know. Have fun.